All right. One way that you can use completing the square is you can convert from standard form into vertex form, okay, just by working with your equation. And the way that you would do that is you follow all those same steps that we did for completing the square, okay, except you're going to work on the same side of the equation rather than working on both sides of the equation. And so there's be a slight difference, but hopefully you can pick up with what that slight difference is. Okay, the first thing I'm going to do is I'm going to rewrite this, and I'm just going to group my x terms together, leave a space to complete the square, and instead of moving my constants to the other side, I'm just going to isolate them in the same side of the equation. Okay. So this will be converting from standard form to vertex form. Okay, so step one, we're going to isolate our constant. Again, we are going to stay on the same side of the equation, so the way to isolate it is with grouping symbols, okay, or parentheses. Okay, once I isolate my variable, I can now complete the square. And I'm going to use the same steps. I'm going to take half of b. So my half of b value, I get -2. Half of -4 is -2, and I'm going to square that. Okay. So squaring -2, I get a +4. Now, if you're working on separate sides of the equation like we did here, you can balance the equation by adding this to both sides of the equation. But what's happening if we stay on the same side? How do you balance a +4 if you stay on the same side of your equation? How do you undo +4? You subtract. Okay, so once you square it, you're going to add it inside your grouping symbols, and you're going to subtract it outside your grouping symbols. Okay, so this allows you to maintain the balance of the equation. You haven't changed anything, just the form. But what this, again, enables you to do is to write the grouping portion as a binomial square. Once you write this as a binomial square, it's in your intercept or it's in your vertex form. So all I need to do now is rewrite this grouping symbol, or the terms inside the grouping symbols, in my binomial square form, which will always be x and then half of b. So half of -4 was a -2. And now I can combine my constants here. A +3 and a -4 gives me a net of -1. And so what I've done is I've converted from standard form into vertex form. And again, the usefulness of this, especially if you go on to math classes where you're not allowed to emphasize your calculator as much as in here, is you can now answer your questions. Where is the vertex of this? The vertex is the x-coordinate that gives you 0 here, so 2. And the y-intercept, or the y value that's this shift, -1. So is our graph opening up or down? Up. So when we look at this, we have our vertex to -1. We know it's opening up. Okay, now, which of these forms is it easier to find the y-intercept? Standard form or vertex form? Standard form, the y-intercept is very easy to find, right? What is our y-intercept? It's just our constant in standard form, so 3. So 0, 3 is one of our points. So we can sketch this graph really easily, and we can mirror this point across the way. So it'll have the same y-coordinate. We just need to move 1, 2 units to the right. And so we get our sketch very quickly just by using kind of a combination. The given standard form, rewrite it by completing the square and put it into vertex form. And if you needed to find what your axis of symmetry was, it's x equals 2. It's a vertical line that passes through the x-coordinate of your vertex. Okay. All right, if you're working through this, step 1, group our x terms, move our constant outside the grouping. Step 2, complete the square. So we take half of our b coefficient, half of -8 is -4 squared is 16. So if we add 16 to this side, we can balance it out by subtracting 16 from the same side. And what this now allows us to do is rewrite as a binomial square. So the two terms will be x and half of this, -4. Combine our terms outside, -15. And so now when you work to solve this, you have your vertex. Okay. Our vertex is the point 4, and then down 15. Okay, so here is our vertex. Our graph is going to open, what, up or down? Opens up, so I'll label below here. Hey, what is my y-intercept going to be? 1, so I can plot that point as well. And so now my sketch winds up being pretty easy to do. And I have my graph. Okay. Now, let's take a look at how we got this point here. Okay. We took our b value, and we did what to it? Divided by 2. And again, when you find your x-coordinate here, the x minus 4, your x value is always just going to be the opposite of this, right? The opposite of whatever is being subtracted from it. So if we take the opposite of that, well, do you guys remember when we first started with standard form, how could we find the vertex? Negative b over 2a. In this case, a is a 1. So really what we did here is it's the same thing. It's the same process, the negative b over 2a, to get our x-coordinate of the vertex. And then you can substitute that in to find your y-coordinate. In my opinion, completing the square may be an easier way, especially if the coefficient's a 1. Does everybody follow this process? Okay, I'm going to add one element of complexity to it. What happens when your coefficient is not a 1? Can you still solve all of these? All right, so once again, always look to factor it first. I mean, if you can factor this, it might be an easier problem. When you're looking at this, you're not going to be able to set up factors. So let's talk through the process of completing the square here. Okay, you're still going to group your x terms together. Okay, the added step, if you have a coefficient of something other than 1, is you need to factor that coefficient out of just the grouped terms, so just your x terms. So if my coefficient in front of x squared is a 2, inside the grouping symbols here, I need to factor out a 2. So what that would look like is take a 2 out of 2x squared, and I'd be left with a what? X squared. Take a 2 out of negative 6x, and I'm left with a negative 3. Do I need to take a 2 out of this positive 1 here? No, because I've already removed that from my grouping. So I'm just looking at the grouping terms. And when I do this, I still want to complete the square. So now instead of working up here, I'm now working with this as my b value. Okay, so when I complete the square, I'm taking half of negative 3, which is negative 3 halves, and I'm squaring that. So if I took negative 3 halves and squared it, you just square the top and the bottom independently. So what's the square of negative 3? So plus 9. And what's the square of the 2? 4. So I'm adding 9/4. And now, in order to balance this equation, here's where the complexity, that extra step of complexity comes in. I didn't really just put a 9/4 into this equation. I put a 9/4 times what? 2. So when I balance the equation, I have to take into consideration this multiplier out front. So what is 2 times 9/4? 18/4, or, so again, if you think of 2 times 9/4, the 2 and the 4 cancel, leaving 9/2. So instead of, I didn't really add 9/4 inside this equation. I actually added 9/4 times 2, which is 9/2. So how do I balance the equation? I undo 9/2. Okay, so you do have to make sure you balance the equation correctly when this is the case. But then everything else winds up being the same. So we can now simplify this as a binomial square. It still fits that pattern of the first term of x. The second term is half of this b value. So half of -3 was -3/2. And then we just combine our constants here. So in terms of halves, so we want to write this in terms of the same fraction. Plus 1 is how many halves? Plus 1 is equivalent to, I could just rewrite it as 2 halves. So what is 2 halves minus 9 halves? -7 halves. And so here is my vertex form. It still gives me all the information I need for my graph. Okay, so my vertex is now at the coordinate. The vertex will be at 3 halves, -7 halves. My axis of symmetry is still x equals 3 halves. My y-intercept is still, you can still find that using your original standard form, so plus 1. Okay, so if I plot this, so here's my, again, 1.5, and then down 3.5. So right here about is my vertex. I can label it 3 halves, -7 halves. My y-intercept is 1. And so once again, I can just sketch my graph. And it's consistent with all the other rules that we've gone through for these graphing problems.